So I want to introduce this idea of Bayesian thinking or Bayesian updating or Bayesian reasoning as a potential tool that folks can use when working with various bits of information, some of it confirming, some of it disconfirming, and trying to figure out how to aggregate that. And I'm not necessarily sure that this is the best way to work with information, but I think that understanding it is useful for recognizing some of the biases that come in. So I'd like to talk about sort of Thomas Bayes, the equation that he came up with for compiling and aggregating information, give an example, and then talk about sort of the qualitative, like how would you use this? What should you pay attention to be able to use the insights of Bayesian thinking when working with information on your own? So I'll start by just introducing Thomas Bayes. He was an English minister and a mathematician living in, I think, like 1680s, and he was interested in questions of probability, and particularly how do you adjust your probabilities when you get a new piece of information coming in. And so he wrote up a paper on this and sent it to the English Royal Academy of Mathematicians, and they thought this is fantastic, and maybe it will help us with gambling, and then they put it on the shelf. And he kind of got resurrected. His work got resurrected in the last 100 years by statisticians who were able to sort of say, wow, so some of what he's doing is computationally intense, but now that we have computers, we can actually use this. And there's sort of a whole branch of statistics that's grown up around Bayes' equation, which I'll introduce here. So Bayes' equation, it's a little messy. I'll talk about it, sort of what it's doing, because some people really like math. And then I'll sort of shift over to a visual that I think maybe makes it a little bit more intuitive with a story to kind of figure out what the heck is happening. Okay, so we're trying to calculate what's called the posterior. That's that part at the end of the equal sign, the P parenthesis A line, B close parenthesis, which we read as the probability that A is true conditional on observing B. So we have a belief, an initial probability estimate, and we have a new piece of information that comes in, that's B. What does that mean for our new probability estimate? And to calculate that, we're going to multiply two things together. One is the probability of observing B if A is true. So that's the PB line A. And then we're going to multiply that times the probability that A is true. And then we're going to divide that by the probability of observing B, whether A is true or not true. And that's going to give us our updated probability estimate, our posterior. So the example that I'll use for this is kind of drawn from my own work on civil wars and negotiation. And so there's a way of describing groups as total spoilers when they're not interested in negotiating, they're fighting to the death. And you wouldn't necessarily want to initiate negotiations with a group that's a total spoiler, but turns out total spoilers are fairly rare. I'm giving that a probability estimate of about 5%. The vast majority of rebel groups are actually willing to negotiate. They're actually policy focused and are looking to make progress. And so you can actually work with them and negotiate solutions. In fact, the majority of civil wars now end in negotiated settlement. Okay, so maybe I've advised a leader to initiate negotiations with the rebel group on the grounds that they're unlikely to be a total spoiler, and then we see that rebel group using extremist rhetoric in response, and a leader might come back to me and say, wait a second, you told me that they were unlikely to be a total spoiler, and yet here they are laying out all this very extremist rhetoric. I just can't believe that they're actually, willing to negotiate, and they're not a total spoiler, that they're actually policy focused. And I might counter and say, well, hold on a second. Let's apply Thomas Bayes' equation to this. So we want to know, what is the probability that a group is a total spoiler now that we've observed this extremist rhetoric? And so let's begin by simply asking, if the group is a total spoiler, right, how likely would we see extremist rhetoric? I'm guessing the vast majority of total spoilers are using extremist rhetoric because they have extreme positions. And so I'll say 95%. That's what we would observe for the probability of B conditional on A. Then we're going to multiply it by what we thought initially was the probability that a group is a total spoiler, which was 5%, 0.05. So we're multiplying that across the top, and now we're dividing that by the probability of observing B. of extremist rhetoric. And we certainly observe extremist rhetoric when we have a total spoiler. 95% of the time that happens, but that's only 5% of the total. So we multiply that 95% times the 5% to get part of the probability of observing B. But in the other 95% of the time when we aren't working with a total spoiler, some of those groups also use extremist rhetoric. In fact, maybe I'd say about 30% of the time. Maybe because they're trying to lay out a tough bargaining position, or they're trying to deal with internal disagreements within their own group, right? There's reasons why a group might use that kind of extremist language, even if they were still willing to negotiate. And so when we multiply the 95% for groups that are not total spoilers times that 30%, it sort of aggregates out, and we combine that with the other, basically the gray shaded areas. We find that 33.25% of the time you're going to observe extremist rhetoric. Just should be expected. And now that we know that, we can calculate our posterior and find the probability that a group is a total spoiler, and it's around 14.3%. So more, almost triple what we thought before. But it's still a far cry from saying that this group is absolutely a total spoiler and we shouldn't sit down and negotiate with them, because that's not what the evidence is telling us. And so I think that's probably less than people would have initially thought if you had told them 95% of total spoilers use extremist rhetoric. And that gets us to what I think is really useful about Bayes' equation and thinking like a Bayesian, because it helps us to think about what the information we have can actually tell us. And so the first thing I would maybe say is that human beings are really bad at aggregating probabilities. We tend to focus on that top line. The 95% of total spoilers use extremist rhetoric. That kind of information or that kind of thing will ping for us in a way that doesn't necessarily help us understand what's actually going on. So just being aware that we as human beings aren't necessarily the best at working with probabilities is useful. A second thing that is useful about Bayesian thinking is that when we have confirming evidence, we need to ask not just, does this information, support my belief, but we need to ask ourselves, if I was wrong, would I still see this confirming evidence? And if the answer is yes, then it's actually pretty weak confirming evidence. And if the answer is no, then it's actually pretty strong confirming evidence. And we can see that again with this sort of diagram, right? So if I believe that a group is a total spoiler, and I ask myself, I'm seeing this extremist rhetoric, would I see that extremist rhetoric that supports my belief that this group is a total spoiler? If they weren't a total spoiler, I need to recognize, well, actually, I might. About 1 in 3 times, 30% of the time, I would see that. And so maybe that gives me pause before I say, aha, I have evidence that really supports it. Now, if this evidence was stronger, it would look like this, where the total spoilers are 99% likely to use extremist rhetoric, and not total spoilers, policy-focused groups would use extremist rhetoric only 1 or 2% of the time. That gap between I'm right, and that's why I see this information, versus if I was wrong, I would never be seeing this information is what's really important. And so the more extreme those differences are, the stronger your evidence. The less extreme the differences are, the less useful your evidence would be. Likewise, when you have disconfirming evidence, right? When something points against what you were initially believing, you should ask yourself, well, wait a second. If I'm still right, is there a reason why I would see this kind of contradictory information? And if the answer is yes, then maybe that disconfirming evidence isn't actually all that telling. If the answer is no, then maybe that information is a little bit more telling. And so I guess the example I could give you here is if there's disconfirming information and I believe that a group is a total spoiler, I would ask myself, well, what are the differences? Like, how often do I see total spoilers using extremist rhetoric? And if that answer was 50%, and I sort of turned and looked at non-total spoilers and how often they use extremist rhetoric, and it turned out to be 50%, I would say, yeah, you know what? I'm not really going to build too much off of observing extremist rhetoric, because that seems like the kind of thing that contradicts what I believe, but also is something that could fully happen reasonably if I was wrong or if I was right. And so I'm not going to necessarily lean too heavily on that. I'm not sure that this is the most intuitive way to think about information, and I think there's some limited value in Bayesian thinking and reasoning, but I think it's worthwhile to sort of have in the back of our mind when we do find ourselves in those situations of aggregating probabilities and thinking about what does this new piece of information mean, to sort of ask ourselves about what would I see if I'm correct, and what would I see if I'm not correct, and how does that square with the evidence that I have in front of me, and maybe it'll allow us to avoid overreacting or relying too heavily on a piece of information that doesn't actually tell us as much as we thought it did. That's the goal.